Hello, this is Kathy Biker from Texas Lutheran University, and this is a review on Chapter 4 for my College Algebra Math 133 classes. And the first question on worksheet number 1 is this function one-to-one? Which means, do all the x's have only one partner, and do all the y's have only one partner? If I graph it, I can see easier because if I go, it's a parabola because there's an x squared and it's up 4, so it's graphed like this. Okay, so if I look at it, it passes the vertical line test because every vertical line I draw, it only passes through it once. But when I draw a horizontal line through here, it passes the graph in 2 spots, which means some of our y's have 2 partners. And you can't have that if a function is one-to-one. So the question is y equal x squared plus 4 a one-to-one function? The answer is no. The second part says, find the inverse of this function 4x plus 3. So I'm going to rewrite it as y equals 4x plus 3. To find the inverse, you switch the x's and the y's, and you solve for y. So I'm going to kind of draw a line here because this is a separate problem. I'm going to minus 3, and I get x minus 3 equals 4y, and then divide by 4, and my y is equal to x minus 3 over 4. But my y can be written another way. It can be the inverse of f, is written like that, x minus 3 over 4. So this is the inverse of this function. It means if I graphed them, they would be symmetrical to the y equal x line right here. They would be on opposite sides and be symmetrical. Okay, problem number 3 is going to take me quite a bit of room, so I'm going to erase. And I need more room for this problem. Okay, so let's start with problem number 3. It wants to know if f of x is x plus 1 over x minus 2, and if g of x is 2x plus 1 over x minus 1. We want to know, are they inverses of each other? It's wanting to know, does f of g of x equal x, and does g of f of x equal x? Well, I'm going to take the first one here, f of g of x. Well, g of x is this right up here. So this is really f of 2x plus 1 over x minus 1. So all of this has to be put in place of the x in the f function. So here's my f function. So in place of the x, I'm going to put all of this. So I'm going to put 2x plus 1 over x minus 1. And then I have a plus 1 also on top. And on the bottom, in place of this x, I'm going to have 2x plus 1 over x minus 1. And then I have a minus 2 on the bottom. Alright, so working with the top, I need to have a common denominator. Well, I can rewrite 1 as x minus 1 over x minus 1. So I end up with 2x plus 1 plus x minus 1 all over the common denominator x minus 1. And on the bottom, this is really 2 over 1. So my common denominator is going to be x minus 1 and I'll multiply negative 2 by x minus 1. So I end up on top with 2x plus 1. Then I have a minus 2 times x, which is minus 2x. And a minus 2 times a minus 1 is plus 2. All of that is over x minus 1. Well, really what I have is, look on top, don't be discouraged, it looks horrible, I know, but this is really a complex fraction, but I'm going to combine like terms. So the 1's cancel on top, and I'm left with 3x over x minus 1 divided by the 2x's cancel, and I have 3 over x minus 1. Well, it's looking a little better, but I'll write it in this format. 3x over x minus 1 divided by 3 over x minus 1, which is really 3 over x minus 1 times x minus 1 over 3. Remember, when you divide fractions, you change to multiplication and flip the next fraction. Well, my x1 is 1's. They all both cancel. And up here I have 3x, and on bottom I have a 3. So I'm going to cancel my 3's, and I'm left with x. Well, half of it looks right so far. So I'm going to do the second half, g of f of x. Well, f of x is x plus 1 over x minus 2. And that means I have to put all of this in place of the x into the g function, which is 2 times x plus 1 over x minus 2 plus 1 is on top. And on the bottom, in place of the x, I'm going to put x plus 1, x minus 2. This is all into the g function. Now I'm going to take away 1. Okay, so again, on top, I have to have a common denominator of x minus 2. And this is really 2 over 1. So 2 times x and 2 times 1 plus let's see if my marker will work here. Plus x minus 2, and all of that's over my common denominator, x minus 2. Now we work with the bottom. Again, we need a common denominator of x minus 2. So I'll multiply 1 by that, and I get x plus 1 on top minus the x minus 2. So minus x, and minus a minus 2 is the same as plus 2 over x minus 2. Again, it's a complex fraction, and so I want to combine like terms. My 2's cancel, so I'm left with 3x over x minus 2. And on the bottom, my x's cancel, I'm left with 3 over x minus 2. So I'm going to rewrite it, 3x over x minus 2 divided by 3 over x minus 2. But that's really a multiplication problem. And I flip it. And now I can cancel like terms. My 3's cancel, my x minus 2's cancel, I'm left with x. So the question is f and g, are they inverses of each other? Well, I worked both out and got x, so the answer is yes, they are inverses of each other. Okay, I'm going to erase that, do problem 4 because I don't have a lot of room left. Okay, so next is problem 4. Problem 4 wants us to look at this graph and tell if it is a one-to-one function. Okay, remember it has to pass the horizontal and the vertical line test. So the vertical line test, I can draw any vertical line, it passes it one time. I do the horizontal, again it passes it just one time, so this is a one-to-one function. That's the end of worksheet number 1 for the Chapter 4 review for college algebra.